For thousands of years, people knew the incredible power of steam. They watched boiling water push the lid off a pot, but no one imagined that this simple force would one day reshape civilization. The story begins nearly 2,000 years ago. Around the 1st century AD, a Greek engineer named Hero of Alexandria built a strange device called the Aeolipile. It was little more than a hollow metal sphere mounted on pivots. When water inside was heated, steam escaped through 2 bent tubes, causing the sphere to spin rapidly. It was the world's first recorded steam-powered machine, but Hero never intended it to perform useful work. To him, it was a scientific curiosity, almost like a toy used to demonstrate the mysterious power of steam. After his death, the idea faded into history. For more than 1,500 years, almost nothing happened. During the Middle Ages, people relied on horses, windmills, water wheels, and human muscle. Mines became deeper every year as Europe demanded more coal and metals. But the deeper miners dug, the more water flooded into the tunnels. This wasn't just an inconvenience. Entire mines had to be abandoned because workers simply couldn't remove the enormous amounts of water. Buckets and pumps powered by horses were no longer enough. A completely new solution was needed. By the late 1600s, inventors across England began asking a bold question. Could steam itself be used as a source of power? One of the first men to seriously explore this idea was the French physicist Denis Papin. Papin had already invented an early pressure cooker, proving that steam could build tremendous pressure inside a sealed container. He believed that this pressure might someday move machines. Although Papin never built a practical steam engine, his experiments inspired many other inventors. Then another English engineer stepped forward. He is Thomas Savery. In 1698, Savery patented a machine designed specifically to pump water out of flooded mines. His invention worked without pistons or moving cylinders. Steam filled a sealed chamber, forcing water upward. Then cold water cooled the chamber, creating a vacuum that pulled more water inside. Repeating this cycle slowly lifted water from underground. It was an ingenious idea, but it had serious problems. The engine could only lift water from relatively shallow depths. High steam pressure often caused dangerous failures, and the machine consumed enormous amounts of fuel. Mine owners soon realized it wasn't the perfect answer. Still, Savery had proven something extraordinary. Steam could perform useful work. That single achievement changed the direction of engineering forever. Soon, another inventor saw how the design could be improved. His name was Thomas Newcomen. Instead of relying only on steam pressure, Newcomen introduced a moving piston inside a large cylinder. Steam filled the cylinder, then cold water was sprayed inside. As the steam suddenly condensed into water, it created a powerful vacuum. Atmospheric pressure pushed the piston downward with tremendous force. That motion operated giant wooden beams connected to mine pumps, removing water much more efficiently than ever before. In 1712, Newcomen completed the first practical atmospheric steam engine. For the first time in history, a machine could continuously perform heavy industrial work without relying on animals, wind, or flowing rivers. Across Britain, mining companies rushed to install Newcomen engines. Hundreds of them began pumping water from deep underground. Coal production increased dramatically. But despite this success, there was still one enormous problem. Every single stroke of the engine wasted huge amounts of energy. The cylinder was heated by steam, then immediately cooled with cold water, only to be heated again seconds later. This constant heating and cooling consumed incredible amounts of coal. The steam engine worked, but it was painfully inefficient. And that inefficiency would soon inspire one young engineer to create a machine that would transform the entire world forever. The young engineer who would change history wasn't trying to invent a new machine. He was simply repairing an old one. His name was James Watt. In 1763, the University of Glasgow asked Watt to repair a small model of a Newcomen steam engine used for teaching students. As he examined the machine, he noticed something that others had accepted for decades. The engine wasn't weak because steam lacked power. It was weak because it wasted heat. Every cycle, the cylinder became hot from steam, then was cooled with cold water to create a vacuum. Moments later, it had to be heated all over again. Most of the energy from burning coal disappeared just reheating the metal cylinder. Watt believed there had to be a better way. For months, he studied the problem. Then, during a walk on a Sunday afternoon, the solution came to him. What if the steam could be cooled somewhere else? Instead of cooling the main cylinder after every stroke, Watt designed a separate chamber where steam could condense into water. The main cylinder would remain hot all the time, while only the separate chamber became cold. It sounded like a small change. In reality, it was one of the greatest engineering breakthroughs in history. When Watt built his improved engine, it used far less coal than the Newcomen engine, while producing the same amount of work. For mine owners, factories, and businesses, that meant enormous savings. But Watt faced another problem. Building steam engines required money. Fortunately, he met a wealthy businessman named Matthew Boulton, owner of the Soho Manufactory in Birmingham. Boulton immediately understood the importance of Watt's invention. The two formed a partnership that would become one of the most successful collaborations in industrial history. Together, they improved the engine even further. Watt added better seals to reduce steam leaks. He designed mechanisms that converted the up and down movement of the piston into smooth rotary motion. That single improvement changed everything. Earlier steam engines mainly pumped water. Now, steam engines could turn wheels. Factories no longer needed to be built beside rivers. Machines could operate anywhere coal was available. Textile mills, flour mills, ironworks, and workshops suddenly had a powerful new source of energy. For the first time, production was no longer limited by nature. Steam power was beginning to reshape society itself. As demand grew, Boulton and Watt installed engines across Britain. Every new machine increased productivity. Factories became larger. Manufacturing became faster. Cities expanded around industrial centers. Historians would later call this period the Industrial Revolution. But the story of the steam engine was still far from over. The next generation of engineers would take steam power beyond factories and put it on wheels and ships, changing transportation forever. By the early 1800s, steam engines had transformed mines and factories, but they were still enormous machines. Most of them were fixed to the ground, powering equipment through giant beams, gears, and rotating shafts. Few people believed they could ever move themselves. One engineer refused to accept that limitation. His name was Richard Trevithick. Unlike James Watt, Trevithick believed steam engines could operate with much higher pressure. Higher pressure steam meant smaller cylinders, lighter engines, and much greater power. Many people thought it was too dangerous. Boilers had exploded before, and high-pressure steam had a frightening reputation. But Trevithick continued experimenting. In 1801, he built one of the world's first full-sized, steam-powered road vehicles. Nicknamed the Puffing Devil, it carried passengers under its own power. Although the machine was unreliable and eventually caught fire after being left unattended, it proved something extraordinary. A steam engine could move itself. 3 years later, Trevithick achieved another historic milestone. In 1804, his steam locomotive pulled loaded wagons along iron rails in South Wales. For the first time in history, a steam-powered locomotive carried heavy cargo on a railway. The journey wasn't perfect. The engine was so heavy that it damaged some of the rails. Even so, the demonstration showed that rail transport had a remarkable future. Then came another engineer whose name became almost synonymous with railways, George Stephenson. Stephenson spent years improving locomotive design. He made engines more reliable, more efficient, and strong enough for everyday use. In 1825, the Stockton and Darlington Railway opened in England. Stephenson's locomotive hauled both coal and passengers, becoming the world's first public railway to use steam locomotives successfully. Just 5 years later, another breakthrough arrived. In 1830, the Liverpool and Manchester Railway connected two major cities using regular steam-powered trains. People could now travel faster than ever before. Goods that once took days to transport could arrive within hours. Railways spread rapidly across Britain. Then they spread across Europe. Soon they reached North America, India, Australia, and many other parts of the world. Steam didn't stop on land. Engineers also began fitting steam engines into ships. Unlike sailing ships, steamships no longer depended entirely on the wind. They could travel on schedule, navigate rivers more easily, and cross oceans with greater reliability. Global trade accelerated. Travel became faster. The world suddenly felt much smaller. Within a few decades, steam engines had powered factories, transformed transportation, expanded international trade, and connected distant cities in ways previous generations could never have imagined. What had begun as a simple observation of boiling water had become the driving force behind the modern world. But by the late 19th century, another technology was beginning to emerge. Electric motors and internal combustion engines were quieter, cleaner, and often more efficient. Slowly, steam began to lose its dominance. Yet its legacy remains everywhere. Without the steam engine, there would have been no industrial revolution on the scale the world experienced. Modern factories, railways, global trade, and many of the technologies we rely on today were built on the foundation laid by those early steam pioneers. The steam engine wasn't just another invention. It was the machine that gave humanity the power to transform civilization.